still takes the same 4 characters of X, otherwise you don't have the A, but you don't need all the 3 characters. It's enough to, you are welcome to ignore the last one, ignore the G, and just match the first 2. So you'll match you look at the best match that is obtained by connecting all the 4 characters to only the 2 characters. So in this case, we are in the C of the whole of the M characters, but only the first n-1 characters. We don't lose anything by adding the nth characters. It is unmatched. However, possibly, in the let's make this C into a G. I still cannot match this A to G. Nevertheless, I can match this G to this G, but then A is unmatched, so I might as well ignore this A completely and look at the first 3 characters of X, right? Because A is unmatched, and stick to the 3 characters, the whole of Y. Which one of these 2 values should I take? The one that gives me better value, the one that I have more segments to match. So if X, M, and Y, N are different characters, then C, M, N is just the better of the 2 matchings that you can take. Either drop the last characters of Y or drop the last characters of X. What's the rationale? Either way, we are looking at the problem by recursively solving a simpler problem. M and N are becoming smaller and smaller in this recursive way of thinking. I mean, I still don't know what is CMN, but I'll be able to solve it if I know the solution to shorter strings. Either make X shorter or make Y shorter. Okay. Everybody is happy so far? Makes sense? It's a bit abstract. Look at this talk, look at the previous talk. It takes a bit of time. So, what happens if M and N are not the last character? What happens in this case? If M and N are not the last characters, that's actually, there is plenty of characters over here, so there will be a Q here and Q here, and R over here. But somewhere, let's add T over here that I don't have to match to anybody. Somewhere there is the very rightmost segment. Let's call it the most rightmost. Segment. Hopefully my solution contains at least one segment that I can match. So if the oracle comes and tells me, check every pair of I and J to be, maybe this is your lucky segment, that is a rightmost segment that you can match, it is a R and R, use this segment, use this solution. And since I'm going to check every possible I and J, in one of them I will pick to the very last segment. Okay, let's see a quick example already. We can already solve it. So basically our recursive formula, putting here as a theorem, but the theorem is going to dictate the algorithm, is if xi and yj are the same characters, then cij, the maximum that you can find, is just ci minus 1, j minus 1, match the last characters and add 1 to the count. And j are the same characters, you then never lose by matching these characters, because essentially we are going to check all possibilities of I and j. If xi and yj are different, then cij is just a maximum of ci minus 1, ci minus 1j, cij minus 1. Let's run a little example. Okay, let's play with this example. AR, BR, CR versus ABC only. So what are the indices? 1, 2, 3, 4, 5, 6. 1, 2, 3. As usual, this is X, this is Y. And I start with the very last character, C of everything in X. I'm sorry, I start from the case of, how do I want to do it? Let's just play with this example. I still don't want to show you the whole algorithm because the actual algorithm going from the opposite direction. But please tell me, can I use, is X M equals Y N? That is the last characters of X equals to the last character of Y? It is not. This is R, this is C. So in this case, we will take either the maximum when we drop the R or the maximum when we drop the C. And because we see the solution right here, this solution C MN is just C of, if I want to drop the R, help me with the indices. What should I write right here? C of 6 and 3 equals, in this example, to C of, remember, it's either M minus 1 N or M N minus 1. Which one of the two? Have a check. C of M minus 1 N. That was Jacob. Thanks again. What? This is R that is going not to be matched. So I'm looking at C of 5 and 3. M minus 1, but then N stays the same. Which of the two cases should I apply right now? The case that xi equals yj or the case of xi is not yj? Somebody else, which is not Jacob? Please, not everybody at once. I'm trying to find the maximum match. I gave up about matching this R, so as far as I know, this R was never there. It's not going to be matched. Not in this particular problem. So I'm looking at the problem of matching everything in Y to matching the first 3 characters of, the first 5 characters of C, and look at the very last characters, the ijth characters. It is the same character. It is a C. Right. So C of 5, 3 equals, in this case, 1, because I just earn 1 segment, plus, help me with the indices, in case that I can find a segment in the matching. What's the numbers that I write right here? I decided to use this segment as part of the matching. C of 4 and 2, absolutely. You cannot double use this C. You decided to use it in the matching, that you're taking 5 minus 1, 3 minus 1. So it would be C of 4 and 2, which I still don't know, but this C is gone. So right now I'm concentrating on the first 4 characters versus the first 2 characters. I mean, in the case of B equal R, no, B is not equal R, and here me in the as the oracle tells you give up about matching the R. So this is, remember, I or J minus 1 or I or I minus 1 J. If I give up about this R, then it would be I minus 1. So this is nothing but 1, the same 1 again, plus C of, give up about the R, C of 3, 2, which is C of 3, 2. Which of the 2 conditions? People, I promise that it will be in the midterm. No, I don't, but I'm lying. Maybe it will be in the midterm. C of 3, 2 in this case. Which of the 2 conditions? A few people have unmuted so far. Are people speaking and I don't hear you? Can somebody speak? Can somebody keep speaking? 1, 2. That I cannot. Do I have my Zoom setting screwed up? Yes, it is entirely my fault. Try now. Okay, apologize. I ignored all of you. No bad intention. Yeah. Help. C3, first 3 characters. Y, the first 2 characters. What's the situation of the last characters? Matchable or not matchable to each other? It's definitely matchable because that's B and B. So this would be 1 plus another 1 that I just earned because I matched the B's plus, help, C of, what happened when I succeed to match?
2, 1.
I take I minus 1, J minus 1, reduce 1 from the I because you don't care about this one anymore, so it is 2, and reduce 1 from the J because this is taken. See, 2, 1, so far I have a matching of size at least 2, as you see, and in the C2, 1 for the same reason R I gave up, so it is 1 plus 1 plus C of 1, 1, which is, as you see, I can match the A to A, which will give me the last one. So that will be the 3. Now let's start to make an algorithm out of it. And because we are teaching the correct and incorrect idea of dynamic programming, we'll go through a few tedious steps, even though I could have jumped to the code right now. First, something that will escort us for other dynamic programming problems, that the optimum solution to the big problem, I repeated this mantra many times, uses optimum solution to some sub-problem. Once the oracle told me that this C is matched to this C, then I know that everything in the prefix up to this C should match as best as optimum to everything up to this C. These are my 2 subproblems, 2 minus 3.